sponsor.
Well, yeah, it's DOE, and
then nothing
he's
would
going there
happen.
to meet with them for the home, so I
Well, but
imagine
they
they're
don't,
gonna say
sponsor
yes,
doesn't know about university policy.
but they don't, yeah.
Yeah, but they don't. They're happy with it.
But they
Yeah,
don't,
'cause they're
they
gonna
don't
get
get a
charged.
say at that point.
Well, if there's a line, if it's travel.
If it's their
they-
money,
Yeah, I mean, he's got a huge budget for travel, to go back and forth.
The university still has its own policy.
sure, everybody has a say.
No, because
I agree with Karen.
tobacco has its own regulations.
Right,
Same as
right,
summer has its own
definitely.
regulations, which sponsors could care less
Right,
about.
right,
So,
definitely.
so just because the sponsor approves it doesn't mean the university approves it.
Right, right.
Yeah, so it's a nice condo down for months of the summertime, you know.
I see that.
And
Okay,
I'm
so,
pretty sure the wife is going.
yeah, me having a vacation, right.
Yeah.
Okay, so today we're going to review C again, just because it's been so long, and you've probably forgotten most of this.
Right.
So, quick overview of everything we've learned. You know, a little bit about Linux and some how to declare variables and printing and reading stuff, ifs and whiles, functions, reading from files, parsing, which is what that strtok is all about, and most recently, program design and coding, and the process you go through to make that all work. We're going to quickly review some of these things. So like in Linux, there's ls for listing directories of things, what the files are, and various things. cd is changed to a directory or a folder, depending on what you're used to. Copying files with cp, removing files with rm. Printing your working directory, or basically the name of the current folder, pwd. Compiling C programs with gcc. Editing a file with Emacs, and making a new directory with mkdir. So, standard thing we go through is logging in, starting the command line GUI, going to the directory where the code is, editing the file, compiling, running, and iterating until it actually runs correctly. And you may remember GCC, -o, prog1, prog1.c, for example. And running it /prog1. Okay, so enough on Linux. C. So we've learned how to declare variables so the compiler knows what the heck we're talking about when we talk about variables. So first we have integers, real numbers, characters, and strings. Strings is one of the more recent additions. So integers are declared with the keyword int, real numbers with the keyword double, characters with char, and strings with char, and then this thing in square brackets that says how many characters you want to be able to store in the string. So this guy is the newest and he's a little strange. We can actually do this kind of thing with all the other variables too. But for now, we're just going to concentrate on strings. So it can have a bunch of different characters in it. So, okay, we need to assign values to these variables. So all these, the first three, we can just use the equal sign for assignment. And so we set b to the value 1, c to the value 1.5, p to the value of the d character. Strings, we can't use equal. This doesn't work. We have to use string copy. Of course, we abbreviate in some stupid way. And so we copy that one into this variable. So it's in the same order. Sometimes the variable we want to set is first, and the value we want to set is second. So then there's math. You can do addition, subtraction, multiplication, division. Parentheses can be used to constrain what happens first. So 3 plus b happens first here. Then it gets multiplied by 42, for example. And then there's if. And we use if to decide whether we want to do something based on some circumstance. And these are a very necessary part of any computing language. So the way we do it, we say if, and then we have two parentheses and closing some conditions, and then we have two curly braces enclosing some kind of code, any kind of code, that is supposed to be executed when this condition is true. And this condition can compare numbers with greater than, less than, equals, which is double equals, less than or equal, greater than or equal. So with numbers, these are easy things to do. You can also combine conditions into compound conditions with and or. So you can have A less than B and A less than C, for example. Or you can do A less than B or A less than C. And you can make that get pretty all kinds of ways. So the parentheses is only used to enclose the logical condition, so that part there. And the curly braces are used to enclose those executable statements that you want to execute. And this is similar to a function in some sense, if you think about it. A function has a name, a bunch of stuff that pass the function, and then these curly braces enclose what the function is. So if is kind of like a fancy version of a function, very special like a function. And similarly, in a while, so there's a lot of things in C that are kind of a similar kind of syntax. I never quite mentioned that before, but okay, so functions in C, like printf, that the compiler guys wrote for you, so that it's easy for you to print something to the screen or print something into a file. So you have a string which says what the format of what it is you want to print is, and then you have any number of variables after that that say what variable to actually print. And so this control string has control characters, in this case like %f, which says I want to print a real number. And another control character, this thing, \n, says put a character turn line feed at the end of the line so that we go to the beginning of the next line when we're done printing it. Kind of like the end of the key. And so these commas here separate the various parameters for the printf statement. And you can have space around that comma.
What's the purpose of the C within the print?
The C is the variable that actually we want to print.
Gotcha.
Where this control statement.
Gotcha. Okay. All right.
So if we didn't actually want to print a variable, we wouldn't actually have to have the comma and the C, and we wouldn't use the %f to just print something. And we've done that before too, where you just print something a variable. So all of the above is possible. Okay, so if you're printing variables, you use %d to print integers, %f to print real numbers, %c to print single characters, and %s to print strings. %s and c are practically the only ones that make any sense. These kind of make absolutely no sense, right? D and s. But, whatever. You get used to it, hopefully. Okay, so that's reading. We can also, that's writing. We can also do reading. And when we read, we can use scanf. There's other things we've used. And for now, I'll just talk about scanf to say what you want to read. Basically, it's just like printf. So this says what type of variable here you want to print. And this can be fairly complicated. And like, for instance, say if somebody printed this to a file and you wanted to read it, you could actually use the value of C to %f as a control string here. And it would skip all that other junk, and where it finds that number, it would read it into this variable. So it would would still work. And it would know, okay, I'm supposed to skip all this junk. And it works. And it works pretty well. If that makes no sense, basically, this says what the line you're trying to read from looks like. And so, if it has a bunch of stuff in it you don't want to read, and you know what it is, you can put that stuff there, and it will skip it. So that makes it easy for you to skip junk you don't want to read.
That percent D being the same.
That percent D says there's an integer.
Okay, exactly. That's what. Okay.
There's an integer you want to read,
Okay.
and there's nothing else there.
Okay, and that's a control character, whether it's, so it's the same as if for the printing characters, but you're telling it you want to read it, not write it.
Exactly.
Perfect.
So
Good.
perhaps, I put a space right here. That would mean there's a space before every integer you want to read. And you don't read the space in some sense. It says, okay, I'll look for a space, and then I'll look for an integer, and then I'll read the integer, there. So the only weird thing about this is there's a stupid and in front of it, which says, basically you're supposed to put it in this integer, rather than, and it's an exact copy. I don't know why there's an and there. But for now, it's just something to use. Okay. And then there's the while statement, which is almost the same as an if statement, except it just happens repeatedly. And so, while something is true, do something. And so this will keep happening until this something here is no longer true. So, the key thing there is to make sure that it's true before you get there. So somewhere up here you got to make sure something is true. And then somewhere inside the do something, you better make sure that something ends up being false eventually. Otherwise, it'll just continue forever. Which perhaps is okay, depending on what it is you're doing, but we're quite okay. So, for example.
Adding zeros to my bank.
Yeah, that would be okay.
I would figure out how to write that quickly.
Yeah, definitely.
Spend time doing homework.
Unfortunately, they would find out who wrote it.
I know.
Okay, so here's an example of that.
Leland did it.
You probably didn't do it.
Oh,
Oh, my
yeah.
goodness. You just thought it was funny.
So our condition is n less than 5. So we better make sure that n is less than 5. So we set n as 0, and then we do something, and then we set n to be n plus 1, and it just goes and goes until n becomes 5. N is no longer less than 5, and that is no longer true, and it'll stop. So this is a pretty standard thing that we do if we're counting something. We know how many things there are, and that kind of thing. And this is pretty standard stuff that you do in a lot of code. Okay, so a function. We have this crazy syntax where we have a return type, some name of some function, some arguments that have types, and that can be any number, and then curly braces enclosing some kind of code. So, for example, price of bananas is a function that returns a double, and it takes as its parameters this one integer called the number of bananas. Given the number of bananas, it sets the price of bananas to something, and then it returns that price. So, return price bananas, it's got to be double, it's double, so we're okay. And so all this is doing is saying if you buy a lot of bananas, the price for each is wholesale versus retail. That's all that is. And I have this double / n function, which I like to do to make sure that I know what this curly brace is actually ending. Curly braces can be used for functions and ifs and whiles, and so it's always nice to know which one I'm in. Sometimes you can have 10 in a row that things are ending, and you can't remember which one's ending which.
Have we been doing that function?
Yeah, we have. You may not have been typing it, but I have.
Okay.
Okay, so functions and the preprocessor. You may remember that all of our programs have names in them, and this is really just another function. But it's a special name, so the computer knows where to start running the program from. So every program needs to have a name so that that's where it starts running. Some other commands that we had in our code started with this column, and these are preprocessor commands. So, for instance, an include or a define are two of the preprocessor commands we've used so far. And we've used include to copy code from an external file into our program before the C compiler gets it. So, for example, we did include standard.io.h. So that's so that all those things the compiler guys wrote are code now knows about it. And remember, for functions, before you call a function, the compiler has to know about it. It has to know what the return value is, it has to know what the name is, it has to know what those arguments are, so that it knows you're using it. And that's why we have to do this include crap for all those functions that we want to use to say wrote. And it's an easy way of doing it. You know, the alternative would be for us to go look up a file somewhere and type all the stupid includes in ourselves. That's not right. So this is a good way to do it. So one thing to note about functions is that the names of the arguments that we use in the function definition. So this thing, for example, one of the names, has nothing to do with the names of the variables that we use when we call it. So, for example, we could call price of bananas with the number 3 as the full argument. So it doesn't even have a variable name. So a lot of students think that this variable name has to be the same as the variable name when they call it. Nothing at all to do with it. The only thing is that it darn better be an int, or have equal to 2. So if you try to pass 3.5 to this thing, it'll probably just not even compile. It's not right. You can't pass a real number to an int. So that's all. That's one of the reasons you tell the compiler this definition right here before you use it, before you call it. And it's all part of C and its type system. You've got to know the type of every variable at every point in the program. Otherwise, you don't know what that is. It's just a bunch of bits. You have to know how to interpret those bits. A bunch of bits that are int differently than how it interprets a bunch of bits that are double, or a bunch of bits that are parity. It has to know what it is. There's no chance of it. So, on to more applied examples. So, here's an example of something that we do constantly, which is we read every line in a file. And so we have a string that can hold one line of stuff. And we do a while, and we do an fget, which is file, get, string, or something like that. And we tell it what variable we want to store one line of text in, how many characters we can store without screwing it up, which is one less than what it's declared as, which is all strings and null characters. And then we tell it where we want to read it from. And in our case, This is a special name that C uses for the console. So this will read in the next line from the console, from the command line that we're typing. And it will do that over and over and over and over and over again until fget does not succeed. So fget will not work if the file ends. So once the file ends, this returns false, basically. So this while loop stops. So this will read everything in a file, one line at a time, and then it will naturally stop when the file ends. So it's a very nice way of reading the entire file. Then, for each line in that file, you do something with it. And what we've done in the past is we've parsed it. So it's parsing, and that's that string post thing. So we take that one huge string and we turn it into a bunch of variables. And we read in whichever variables we care about. You can even ignore parts of the line if you don't care about it. So that's that CSV stuff that we did before. We parse it and we get variables. Then with those variables we can calculate stuff or do whatever it is we need to do. And then print something out for that line. And then we're done with that line and we go to the next one. We just do this over and over and over again. So this right here is something that is in almost every C program. Is doing this kind of thing. Reading from a file and doing it over and over and over again. And it can get pretty complicated, but this is the basic syntax for doing that. And then, of course, here's stringtoke. This is right out of the program we wrote last time. So once you've read in that line from some file, and you stuck it in the variable input string. Now, in this case, we're going to use CSV, so we're going to say, okay, this comma here is what separates the different variables in that string from each other. So stringtoke will say, okay, I'll look at that string, and the first comma I see, I'll stop, and everything from the beginning to that comma, I'm going to shove into username. Then, stringtoke, you run it again, and you use null forevermore. So the next comma I see, from the last time I was to this one, I'll stick that in username. And do it again. So from the last one I was to the next comma, I'll shove it into machine name. It just does that. Oh, you just do that over and over and over again for every variable that you need to read. And if you want to, you can even take that variable, and maybe it's a number. You can use this thing. It's another function that, again, the compiler writers wrote for us. It takes a string, in this case, A stands for string, to I. So it converts a string to an integer. And so you better make sure that this actually looks like an integer or this thing won't work.
Why is it an STOY?
It's dumb.
It's okay.
It's really dumb. Yeah.
What's that coming from?
But there's a lot of these dumb things.
I mean, is there any other function that's STOY?
No.
What in this function?
No. And if you really want, you can define a function called string underscore to underscore int, and then just have it be A to I. And away you go. Then it makes sense. And you don't have to care ever again about A to I, because it's done. You use that function everywhere that you want to use it, and you never have to think about A to I again. If you want.
It just doesn't make sense.
I know, it's terrible. So, this is how you can take that one input string, which has a bunch of variables separated by commas, and turn it into a bunch of variables that mean something to your code. So, string and integer. And you can do the same thing with floating point numbers. Okay, so, reading from a file instead of the command line. This is something that we do constantly in Linux, and it all comes down to this character right here. So this right now we're no longer in C. This is the command line. This is Linux. So we run a command that we wrote, which reads from stdin, which means standard in, and instead of reading from you typing in, you give it this thing, and it will read from this file instead. And so it's real easy to write a program that can read from a file or read from the command line. And it's the same program. And you just run it this way. So all you got to know is that this thing just says, okay, read from this instead of from standard in. That's all it means. Now you can also use this, which is the greater than sign, which says instead of writing to the command line, you can write to a file. Now you read from standard in and you write to what's called standard out, and away you go. So what we've done with printf, that writes to standard out without main read. And so if anything gets printf, it goes out to instead. And so now you can write a program, same program, and take different files as input and spew different files as output. So if you had a bunch of test input.csvs, you could use the same program without rewriting it and just run it with each of the different files that you care about using it, and output it to some other different output files. So if you had 10 CSVs, you need to do the same thing in each one. You can do this without putting the file names inside your code, which is that's crazy. So away you go. Same code will run on all 10 files. And there's even more going on there. Make it easier. So it's meant to make things easy for us in the long run. It's difficult to do a shortcut, right? But you do it once, and you run it a million times. And that is the only reason anybody writes code. It's to get things in the long run. Okay, you may remember the program design / coding process. You first start by writing programs by breaking up the problem statement into a few simple steps. And then you continue by breaking each of those steps into substeps. And at the top here, everything is English. You're just writing stuff in English. But eventually you get to the point where you can start writing it in something kind of like C, variable names, things like that. And so once you're down to the point where you think you can code each of those steps as like a function, then that's what you do. You code the lowest level, simplest step in C, and you make sure it works. Key. You write it. You don't write any of the other stuff. You write the lowest level step, the one that you're least sure about, and then you test it to make sure it actually works. And remember, we went through that. Every time we wrote something, we wrote a main program, call it with some simple string to test it. And we just hard code it. Just set it equal to something instead of trying to read it from the file. Make it simple. Just test that chunk of code. See if it works. Make sure that we didn't go over detail. So you're just testing that one piece of code. Once that works, then you can write the other codes, the other pieces that depend on that, and on up. So that every time you're debugging something, you're only bugging the thing you last wrote instead of that stuff from 2 days ago when you started. Because you're not going to remember. And that's a big thing about coding in C is that these codes can get very long. Like, I've written things that are really mine. There's no way a human being can keep track of anything more than like 10, 20 lines. So functions are there to help you make sure that you can keep track of what's going on without remembering every single line of code that you've written. And then testing so that you don't have to think about that much code. Something's not working, but I know I got that one working, so I'm not even going to look there for bugs. I'll just look over here. This last thing that I wrote.
And that's the only way you can stay sane. If everything is possibly buggy, you'll never ever get anything to be done. Now, unfortunately, it is true that everything is buggy. But most of it is far less buggy than your own code, so you deal with your bugs. Okay, and so you test each piece, and you keep coding, keep going up and up and up, and then eventually you stop when you're done. And then you try to run it with some real data. Sometimes your tests were a little too simplistic, the real data's a little harder, and things won't work, so you gotta kind of have to go along and figure that out. Hopefully you were smart in using that. So that is what we've done up till now. And if you have any questions about all that, we can talk about it.
That was very helpful.
But that is the overview of how to program in C using Linux. And all the little, kind of each page is kind of like a cheat sheet into one of the topics that we've done. And some of them even have recipes for how to do it. And so this is something useful for the future, I hope. So what time is it? 42 maybe?
Yeah, it's about
20
42.
Okay. So with what time we have left, I would like to open it up to ask you what ideas you have for programs you want to write.
I was thinking about that, actually. I'm trying to think of something that's fairly simple that I could bring in. Unfortunately, I'm going to give it some more thought.
Yeah, I mean, things can get complicated.
Yeah.
And even the thing I gave you, it was from Jen, but it was a simplified version of what she went through.
Right.
So you can give me something more complicated, and I can try to simplify it for the next time. But I want to basically do what we already did. Go through the design process, the coding process, the testing process for another hunk of code that we haven't written yet, and get you used to doing that. Maybe do it once, twice, 3 times more maybe. And, introduce little tidbits along the way as you go. So that these codes, if not directly useful, are suggestive of things you could actually do. So what really boring thing do you not want to ever do again that you could have this thing do instead?
So one of the things that would be helpful, I'm trying to think of the stuff that I ever have to calculate, because most of the
And it
stuff...
doesn't need to be calculation.
Yeah.
It can be dealing with other things, like somebody owes you a document, and you've got a spreadsheet that has yeses and nos or something, and you can email them, standard email will do that. Anything that's computer related, we can automate. If it comes down to you wringing your necks, well, we can't automate that yet. But we have robots, but not quite yet. So practically anything that's related to a data file, we can automate.
I'm trying to think how we use all the files and how often I get into them and why.
I mean, all too often it'll be looking for something stupid, say. Looking for something overspent. Looking for something underspent. Looking for account numbers that are wrong. Looking for names that are unfamiliar. Why are we paying this kind of stuff? This is what computers are good at. We're abysmal at it. We have to look at each one, read it, understand it, and then go to the next one. And that is painful. There's more than 10 of them, right? You're screwed. So this is something that Jean had to do a lot of. She had to go through her spreadsheets and find codes, short codes, that weren't deep. And this is great at that. She doesn't have to go through these huge spreadsheets and look for things that aren't easy with her eyes. She could do this, and it'll print all of them up. There it is. Now she can look at those and decide whether, okay, man, maybe it's okay. And if not, she flags it and goes and does something. But it saves her all that pain and agony and probable screw-ups looking at it manually.
So one of the things, let's think of one about that. My term by term, so at least 3 times a year, effort certification report that are due from our GSA. I'm supposed to pull a report from the system that comes to me in a CSV file.
Okay?
The data has embedded in it the unique name, but not as a standalone field. I have to reformat the thing every time to get the unique name, and then I have to put a formula in a field to make it @UMISH so that I can send emails out to everybody with standard text about what they need to do. So pulling the report's not a horrible thing to do, it's fairly easy. But then having to format the file and send the email
Yep.
to everybody every term.
So we can do this. This is
Okay.
easy.
So that one would be a good one.
Yeah? And it's only 2 steps, it seems like.
Okay. Okay.
That'll be easy. Any other ideas?
I get a monthly report from Central Campus. It's an Excel spreadsheet that contains data that I have to filter for College of Engineering employees, because it has the entire university, who have not been through a specific process that I'm responsible to get them through. And it has several key pieces of data that is date and person relevant. That is, I have to send each of them an email individually. Some of them it's a second email, which is different data. And I have to CC the HR manager of the appropriate department as well as somebody else who's is in that spreadsheet, identified in the spreadsheet. One of the administrative managers not in the spreadsheet, I know who it is, because I know what department it is. I mean, we can define who it is in the program, because I know who it is.
Right? Yeah?
So again,
Definitely.
okay.
Just like the first one, usually do. That one might be more interesting because we got a filter.
I'm still not thinking of anything. I
Um,
always think of organizing all of our student appointments. It always feels like we're missing somebody. And like we missed a student one year and his wife took the baby to get a checkup and he's on insurance. And it was the faculty spot, it's not. He forgot to tell us he was staying around for another term. We thought he was,
Yeah.
I mean,
Some
I
of
guess
these
how
things,
can, those,
It's
I
not
guess.
possible for the computer to
But that's
deal
like
with
a
it.
small,
Yeah.
yeah, unfortunately,
no,
it's
just,
when
I
we
mean,
have
those
to.
things that just kind of, you have to capture physically.
Yeah.
And that computer would never have, said, hey, go remind that faculty they have a student they didn't tell you about, or.
Yeah. And that's
Or a
tough,
postdoc,
right?
actually, it was a
I mean, you
postdoc
can
that
send all the
was
emails
supposed
you
to
want. Tell me who your students are so I can make sure they're
And
in the
we do
system.
that
Right.
repeatedly.
But you'll get
Here's,
nothing, right?
here's how we build the programming code. If you don't hear from the faculty, they don't get paid.
Well, because we do that, it's always a struggle, like,
If only.
we have some that just don't ever tell us their appointments,
Yeah.
and
if
some
you
that
don't
do,
know
so
about
we're
a
updating
student,
the spreadsheet, and who hasn't told us, and who
That's
has,
it.
and then who told us these, but I don't know how to tell a computer,
Right.
how to, that's just more of us county executive.
Yeah.
Yeah, my retirement speech will address exactly those types of things.
Yeah,
want
I
you
hope
to
you,
know.
hope you print out all those problems.
I'm gonna.
Leave my
I'm
people,
gonna.
please make it.
I don't know how that,
Help us
It
help
will.
you.
It will.
exactly. Exactly.
Yeah. It's
My
tough.
retirement
It's
speech.
tough. Faculty, their first priority is finding money. Everything
And
else,
I totally get that,
is a
like, we need to
distant
keep
second.
them, you know, we need to keep them active
yeah.
without hounding,
And
and
they-
I
But if they're not
never.
spending the money they're finding, then it
Well,
makes
there's
no
that too.
difference.
There's always something, yes. So, accounting. Is there anything you do for your faculty, say like every month you give them status?
I do give them a status, and I'm not supposed to anymore,
Tough crap, right?
because they want them to
Everything
go
right.
find their own numbers,
Yeah,
and
heck
I
with
always
that.
say, you know,
So what's involved in getting them the status?
from my spreadsheets, and I'm not supposed to keep them in
Right,
there.
right, exactly.
And I have them all pulled into one spreadsheet, and it would be nice, no, it would almost be nice if they could see my spreadsheet like that. 'Cause, like Emory Forts, you know, we're supposed to make them go to Emory Forts and get all their stuff.
Right.
And I did that with somebody yesterday, and he actually noticed
Liked it?
one of his students wasn't
Wasn't
there.
upon it?
Yeah, so, you know, that's
Was
$20,000.
that Tyson who?
No, a Sandy, and getting a extension. And he actually noticed, I don't know how, because he's never looked at them ever. I just had it up on my screen, I'm like, hey, let me introduce you to Emory Reports that I'm supposed to be making you do only, and you're supposed to figure this out all by your invoice out and not come to me, because they want to get rid of me
Right,
completely,
exactly.
but
Yes.
hopefully they
They'll
can't.
do anything to get rid of
Yeah,
it.
and when I'm gone and you have to figure this out by yourself, here's how you do it.
Tough crap.
Yeah,
right?
and they're gonna
Yeah.
go look at Emory Reports, but it didn't show that student appointment. He actually picked up on that, because, it was, Arun, who was only at 60%, not 100%, and we
Yep.
noticed.
Yep.
And he's
Yep.
like, okay,
Yeah, that's-
well then there, under, you know, it said he had 80 grand left, and he really only had 60 grand left, so he wants to only spend 60, not 80, you know what I mean? So it's like,
Yeah, yeah.
but I'm glad that he looked at that. But I would not always, every month, say, okay, here's your true actual numbers. Disregard on reports, which we tell you to go to. Just do what I say. But sometimes it is accurate, you just never know, like,
You
it
never
doesn't get
know,
caught up
and
in the
that's,
system.
of course, a big problem.
You know, that's where we're figuring
Yeah.
out, so I don't know how to automate
Well,
my spreadsheets to give them this
One of
faculty
the other
value.
things I think I would love, and I'll have to think about how to do it, the pain in it is extreme, is onboarding new people and ensuring each step.
right.
People
right.
are notified, things are set up, et cetera, et cetera, et cetera, depending on who the population is and depending on what the title is. So is it an RA, is it a staff, is it a faculty? What component do they need to be notified of? What link do they need to be sent? What document do they need to have?
Right.
Training
You know,
and everything.
and a lot of it can be automated. A lot of it already is, but it's currently I have to stop and think about what piece do they need.
Right. Yeah. Yeah, we should think about that once, write it down, and then we can automate it. I imagine
Like
there's,
even for visitors,
I
there's
imagine
so many
there's
things
quite a
that,
few different
I
types
don't know
of
how
people
Ann-
that we need to
I
deal
got-
with. But, you know, do the main obvious ones first, and as time goes, you can fill in some of the more esoteric
Yeah.
people types.
Right.
Yeah.
But for you, here's what I would like for a accounting every month. I would like to know a simple thing by account, you know, where I am and what's been encumbered, and does this make sense to the end? Then I'd like something like for each student. I'd like to know what they're on and if the money is really there for them and that kind of stuff. I imagine it's probably fairly simple usually, but I know for some of them they get switched around from things.
we do, we were like,
And,
oh, we
yeah.
didn't get money, or
Yeah,
they
exactly.
didn't renew the
And
project,
so,
or,
you know,
yeah.
doing that switching around and, you know, having a historical thing as well as a future idea would be also useful. And have it be the same all the time. Same
Well, I have
report.
a summary that lists like all the accounts here, all the students here, and then their cost, total cost. So then I have that pulled from a different spreadsheet where I calculate the total cost. So they only see, so if they have to say, oh, I'm gonna switch this guy here, they know it's gonna cost $22,859. And they can just move, and then just kind of think, you know, and that helps me help them. Like that was, Hero requested that, and I do it for pretty much everybody now.
Right.
It's so nice. They have it all in one spot.
Yeah, definitely.
And who's ending and who's in their budget period. And
Yeah.
another thing for this budget period, like, you know, because you got,
Oh, yeah.
you should get more money in September, but we got to spend our money now before September, so we
That's
can't
right.
say you have 100 grand, you only have 30 by September. But then, so you split the
Yeah,
appointments
yeah.
accordingly, depending, you know, budget periods to land in between semesters.
Yeah. Yeah,
So it's
coming up
always
with,
tracking, you know, it's just it's a lot of busy work, like always
Right.
tracking and making sure
this
well,
is
here it-
Excel's
that
busy
you can't
work.
really, well, that's just it, and, you know, I'm looking at that.
Yeah,
And then I go home and come back in the morning and make sure I looked at it right before I tell them, oh, you're really not out of money, I just was, you know, my eyes got cross-eyed, and you're actually okay, you know,
yeah.
like giving the faculty a really, but how to make that, I'll think about it as I go through my day.
Yeah,
like,
I mean,
if I-
perhaps there's a format, you know, for presenting this to them that is more convenient.
Mhm.
I have no idea. But we can write a program that presents it that way.
Mhm.
Okay, so, when would you like to meet next?
I won't be here Thursday,
Okay,
but then after that I'll be,
Well,
next
Friday.
week is, I'll be gone Wednesday, Thursday, Friday.
I'm gone all next week.
Oh, you're going on next week?
okay.
So the week after?
Pick a day and I'll go look at my calendar and just log that.
All right, so,
That makes it July 7th.
want to try for July 7th?
That's fine by me. That's
July
on
7th?
Monday?
Yeah, that's a Monday.
Okay. Oh, wait, didn't I tell you that was when I wasn't going to be here?
Oh, I don't know.
I don't remember. I'll look.
You don't remember either?
I
Yeah.
don't remember either. I'll look though when I get back to my office and I'll tell you.